When you say high volume and big auto, what kind of numbers are you talking?
Billions.
What? I love your rack. See that, Tom Utley? Got work to do.
So it's making 24,000 parts a minute.
Ah, that's awesome. Woo! Oh my God, that's scary. You hear that, Grimsville? You can put EDMs in your crawl space. No! Oh my God.
This started in a two-car garage.
Is that right?
Yeah,
Two-car garage.
Two-car
What
garage.
year?
1987.
1987. Hi folks, we are here also in Ohio at a place called Superb Industries. I have not been in yet, but I am really excited because I think we've got some pretty cool equipment and we're going to be taking around with
Edm the Machinist.
Edm the Machinist. Really cool Instagram. Check it out. He does some pretty awesome stuff. And you've been working here now for
5 years.
Cool. What is Superb?
We're a manufacturing industry. Our company, we specialize in high volume manufacturing for automotive and appliance industries. Really any kind of project we'll get into, whether it's stamping, molding, assembly, just as long as it's kind of a high volume and in one of those target sectors, we're interested in doing it.
Because Ed was asking if you're a machine shop, and I don't know, but I kind of thought, I think they use the machine shop stuff to support things like stamping and molding.
It primarily supports our manufacturing, but we do tool and die work for other companies.
Okay.
And that just kind of fills the voids in between large projects.
Got it.
Keeps the tool makers busy, but it's not something we seek out.
Got it.
Just it's a key arrangement with some companies we know very well, and we sell them time when we have it.
Cool. Shall we?
Sure.
And so when you say high volume and big auto, what kind of numbers are you talking?
Billions.
What?
Yeah, we did 1.2 billion parts last year. It's set to go up this year.
It's funny because in the car right up, I was like, I think Adam said that they shipped 1 million parts last year. Apparently, I was off by a dude.
Yeah, huge zeros. Most of our programs are over 1 million parts. So.
Oh my God!
And you just high cycle speeds, multiple parts per head on the press is how we achieve that. And you'll see that.
Holy cow!
Hi, Matt. We'll cut over to our first tool room.
This is really cool.
So we have two tool room machining areas. In this upper tool room, it primarily serves the purpose of putting things together and fixing things.
Okay.
So when you're putting something together, if a screw hole isn't quite lining up and you need to just get on a bridge cord or something and open it up real quick, this is what this is for. Since this is also kind of where we do a lot of our smaller components, where we keep our stock rack and our heat treat oven. Okay. So we've kind of constantly tinkered with the layout, but so far we have a nice flow where it comes off the stock rack into the saw.
Love the vertical infeed saw.
Yeah, these are wonderful for the large plate work we do because you can cut out puzzle shapes out of a big plate and save yourself a lot of milling.
Yeah, that's awesome.
From saw can go into milling. We have two manual decal, kind of a manual CNC decal, and then we have a newer Bridgeport. The thing about the decals is they're not really good at drilling and tapping.
Okay.
They're very excellent mills, whereas the Bridgeport definitely, in my opinion, has a leg up doing hole work.
Do these have a quill?
Yeah.
Okay. I've seen them in museums more than I've seen them in industry, which is probably a sign of the times.
So the quill stroke's only 3.5 inches.
Okay.
Which is limited compared to like a 5-inch quill on a Bridgeport. Mm-hmm. But so you crack these 6 screws loose, and you can rotate this head 90 degrees, and then the whole thing will reciprocate backwards.
Okay.
And then that gives you access to your horizontal spindle.
Got it.
They're actually geared together. You can see when the vertical spindle's going, so is the horizontal spindle.
Okay.
So they're both always running, which is kind of awkward. But
do you use it as a horizontal?
Every now and then we'll have like a big boxy shape.
Yeah. And
it's really, really quick to throw something on there. Or if you have a big plate like that and you need to put a end hole on it.
Sure.
It's a very fast setup. You just throw it up on blocks, indicate it in, and you can start drilling. Running them's kind of weird because like an American pattern machine, you stand in the front, and these you stand to the side. So as you perceive the x-axis,
Yeah, the
it's
axes
moving
haven't changed.
to
Okay.
and fro away from your face.
Sure.
And the y-axis is moving side to side.
Yeah.
So everything's kind of turned 90 degrees, which is a little awkward, but
Do you have a y-axis? Oh, that is your y.
yeah, the
your y
y-axis
is, in the
is
head.
built into the head, and then
Whoa.
Z's on the table.
Okay.
Now the really weird thing about this machine is when you go to horizontal, the work coordinate system doesn't shift.
Okay.
So
Oh,
when
sure.
you're programming a drill depth, so to speak, you're doing
Okay,
your
right.
drilling
Y.
in negative y,
Right.
and you can get into a little trouble with that.
Right.
It's a little awkward, but
Huh.
the later generation machines, they had a switch, so whenever you flip the head,
Oh.
X, Y, Z then turned.
Got it.
But
And it's a 40 taper?
yep,
That's awesome.
it's actually a SK40, which so Cat 40
Okay.
has like a 5/8 11 or an M16 thread, whereas this is integral.
Huh.
So on this machine, there's actually a male thread that goes in,
Yep.
but on this one, it's more traditional, like a CNC, where there's fingers that grab the ring.
Got it.
But
These are both. Oh no, that's the smaller. That's an FP4 and that's an FP.
this is a FP4. This is the same frame. The only difference is this one's CNC controlled.
Got it.
So sister machines, really.
But you spend a lot of time on these, right?
Yeah.
Okay.
Yeah. Primarily what I run when I'm doing machine work.
Got it.
And, really nice if you do like an older style machining where you start from a squared block, simply because you could put a 4-inch face mill in them, and I'm willing to bet these are all square within a couple tenths.
Oh, is that right? Just
yeah.
off the machine.
Yeah,
That's
just off
awesome.
the machine. So whenever they go into grind, it'll
less work.
square up really quick.
Sure.
They don't have to use a lot of fixturing.
And you can run. I'd say some pretty large diameter face mills.
Yeah,
The decals can
and-
take that.
Yeah, I think in vertical we're usually around a 75 to 100 thou depth of cut with that face mill, and
Serious?
it doesn't really care.
Wow.
Just if you look at the ways, there's just a lot of surface area for a machine that's the same footprint as a Bridgeport.
It was a box way design.
Yeah.
Yeah. It's rigid.
For turning, we just have a Clausing 15-inch.
Just like the 17 inch we had. That's
Um,
awesome.
They're very popular lathe, but we don't do a lot of turning in tool and die work, at least in our realm of it.
Got it.
If you look at the components in a die, only a handful of them are round, and it's very basic. So it's not something we do a lot of or have a huge need for, but
Yeah.
it serves our needs well. And
Honestly, that 15 inch is a nice size. The 17 we had was bigger than what we were going to use it for.
we could probably stand to have actually like a smaller lathe, like one of the Harding HLVs, but this is versatile, so we keep it around. Upstairs, we about a year ago added a Okamoto 12x24 grinder.
Yep.
Just helps out our grinding department, just to be able to kind of throw something on, walk away, and let it rip it down.
Yep.
We have a much larger wet grinder downstairs, but having a flight of steps between things really kind of breaks up the flow of the shop.
So this is a 1224.
Yeah.
Okay.
Yeah.
But this is not a new vintage. This is an older machine.
No, this is a 83, I think.
Yeah.
So,
Okay.
uh,
Yeah. Same era.
yeah.
Got it. You like it?
It's a very nice machine. Very flat ways. It's a little, like, I don't like chasing tenths on it because there's like just a little play in the wheel, and I never quite have that amount of confidence I have on a standard surface grinder. But very, very good finishes, nice and flat.
Nice table.
Yeah, it gets used as a table more than a surface
Yeah.
plate, unfortunately.
Right.
But we have it calibrated once a year. Every once in a while, we'll have like a real big automation project, and we'll assemble the frame on this.
Cool.
Just you have a nice flat table, you can
Right.
reference everything. But yeah, mostly it's a bench.
How
So
do you
this
break-
is kind of the heart and soul of our tooling builds. We do all of our own carbide grinding in house.
Oh,
So
really?
our grinder of choice is the Parker Majestic. They're particularly good grinders for a couple reasons. One, they're a wade machine, not a roller machine.
Okay.
And two, they're not a cog drive, they're a belt drive.
Okay.
So, you look underneath, there's actually a tension belt that traverses the table.
Oh, interesting.
And that's really important when you're doing carbide grinding because it allows you to essentially climb grind. It's kind of like ball screws on a manual mill.
Sure. Interesting.
Whereas a rack and pendant style machine will kind of jump on you.
And no backlash.
So, like this was wired, but this was actually designed to be ground. And so a grinder could stop grind into it
Okay.
and not have any problems when the wheel contacts.
Okay.
But-
So we haven't gotten there yet on the tour, but when you talk about grinding carbide, you're talking about work for die sets.
Yeah,
Okay.
yeah, punches and dies.
Okay.
Not so much dies anymore. So
Okay.
if you think about a die, it's a block and it has an opening in it. The way they used to do it is they'd split it in half
Okay.
and then grind each half of the opening on a surface grinder. With wire EDM, that's all gone away. Nobody
Okay.
does it like that anymore. But punch grinding is still very popular. Just because there's a lot of attributes to grinding a punch.
Okay.
The surface finish in the grain direction
Okay.
can really help out in some stamping applications. But even that, wire EDM's getting so good at getting a good surface finish.
Oh, really?
A lot of that's going away.
Even on something that's round, like a punch? Or
Uh,
punches don't have to be round, I guess.
A lot of round punches, what we call Pierce punch, you still see those ground just because it's so economical.
But this is what we're talking about here. So there's different punches or inserts or...
So this is actually a punch holder.
Okay.
So a punch will go in there and there will be a little ledge clamp that
Okay.
holds the punch. But yeah, this is all wire EDM'd.
Is that right?
And then this is the opposite die holder, where there will be a little piece of carbide pressed into each one of those cavities.
Okay.
But,
And what's the material on something like that?
all of our holders, they're usually A2,
Okay. Tool steel.
mid-50s kind of. Wear components, like a clamping surface, that'll be a D2. Most of our cutting, we're into the powdered metals or carbide.
Okay.
Starting to mess around with ceramics
Okay.
for a little bit. But we don't really have the capability to do a lot of the ceramic work in-house.
Okay.
So for now, it's just carbide and powdered metals.
Got it.
You do all the wiring in-house?
Now we do.
Yeah, so you just last week or something, you got another EDM in, right?
Very recently. It's
Can
our
we-
only one.
Can we go look in that grinder again?
Yeah.
So you were saying grinding carbide, but that looks to me like a traditional.
So this is a
aluminum oxide or
traditional, aluminum oxide 60 grit wheel.
You can't grind carbide with that though, can you?
So we use
Okay.
resin bond wheels.
Okay. Got it. Yeah, that's what I was kind of
The
expecting to
3M brand. So there's a band of resin with diamond impregnated in it.
Okay.
You can see this one's about shot.
Okay.
Like how thin that band's getting.
see. Yep.
Um,
So cool to see the sign plates and jigs and fixtures on the grinding.
so here's more of our form wheels, which if we need to grind a contour
Okay.
into something, this is where we'll
Wow.
start. So we have a lot of just angled wheels, a lot of set radii. This sounds really kind of
I
odd.
love your rack.
But what we'll do is width. So let's say we need a angle and it's carbide, and then at the top of the angle there's a radius.
Yeah.
We actually have programs for our Texas Instrument calculators
Stop.
where you enter the wheel radius and you enter the tangent point of the part's radius and the angle, and basically you touch off on the side and on the top, and it'll give you step-by-step coordinates for your Z and Y, and then you can just kind of cheat your way around.
Really?
It takes forever, but
Right.
it's really effective.
That's cool.
So
Look at
we
the
can talk
size
a little
of
bit
those.
about grinding.
Those are for the Okamoto on the bottom there.
Yeah, and those are seated gel wheels. A lot of people will refer to them as ceramic wheels,
Okay.
and those are really, really nice on
Those are big.
on tool steels, which are meant for wear resistance.
Okay.
So like your D2 and your powdered metals. Let's talk about fixtures. So a lot of people, you see like a magnetic squaring block.
Uh-huh.
Those are wonderful. But because a lot of what we do is carbide, it doesn't really apply to us. We can't
Okay.
use them reliably. So we have a lot of our own squaring fixtures we use here. So this is what we'd call a second dimension. So on a
A what?
part,
A second.
second dimension fixture
Okay.
or second side fixture.
Okay.
So on a part, if you think of it like a book, the face of the book is your first dimension.
Okay.
It's always the thinnest. The rib of the book or spline would be your second dimension.
Okay.
And then third dimension would be the top and bottom.
Okay.
So if this were to come in as a heat treated part, black, we would grind the flatness of it down to size.
Yep.
And then next operation, it would go into a block like this,
Okay.
and then we would pin it.
That's it.
That's it. And now we can grind the second side of it
Okay.
without any influence from magnetism or anything like that.
Mhm.
And So you grind one side and then you simply just flip it around.
You're grinding both directions when you do that?
What?
You're grinding both toward the stop as well as the other way? You're not worried about that part flying out? Really?
Yeah.
Okay.
It doesn't take much. Grinding pressure is pretty light, especially on like a small part. We're not taking huge cuts.
Yeah.
We generally leave 10 to 15 stock on a smaller part like this.
Okay.
So I mean, even there's no sense taking a huge depth of cut, like take 5 at once.
Sure.
Because you're saving a minute at most.
Yeah. Got it. I like that though.
So that's how you do your second, and then the third side, real similar. You just pin it into the corner, and you'd have like a spacer underneath.
So you're not marring the part?
Yeah.
Oh yeah, okay.
And then you wind this one all the way in. And what's interesting is if you move these clamps around, you can actually influence the squareness.
Okay.
So if you grind this and you check it on your square gauge and find that it's leaning one way, you can press a little higher or a little lower.
Interesting.
And bring that in.
Will you sweep another edge before you take the first grind? Or do you just put it in there, finger tight it, and then just start grinding?
We'll put it in, finger tight, dust it,
Okay.
check, make sure everything's doing what we want.
Yeah.
So ideally, this clamp would probably be up a little higher, and this one might be down a little lower.
Okay.
I was always taught about a third away from the bottom for
Okay.
your clamping area. But yeah, that's how we do the tops and bottoms of a third dimension.
I like that.
And then, we have all kinds of other weird fixtures for doing stuff. These blocks work on the same concept, but they allow us to orient parts on angles or grind chamfers. And then if we need a specific angle, we can set it up on a sign chuck.
Right.
So here's some more grinding fixtures. This is our balancing rig for the Okamoto.
Okay.
Pretty standard, but we don't really spend a lot of time balancing our 7-inch wheels. And I'm sure that a lot of people would disagree with that, but what we get a lot of improvement from is you true it, and then you true the sides.
Interesting.
And so any variance in thickness, that really brings the balance right into a point where it's not a problem for us.
And you don't have
I'm
to
not
spend the
saying it's
time.
perfectly balanced, but it works.
So you just use the same style diamond dresser to clean up all that. Interesting.
Like I said, I'm sure some people will disagree with that. And yeah, it's not perfectly balanced, but it's effective. So here's just a XL version of the fixtures we were talking about earlier. A lot of motorized spin fixtures.
Yeah.
This is what we call a flat spin. So if you have something shaped,
Herman Schmidt.
have something shaped like a top hat, if you can imagine, you can grind the height of it, and then that flange surface, because it's rotating.
Yep.
And something about rotary grinding gives you a really super finish.
You're grinding on axially and radially sometimes, or just on the floor?
Just on the floor.
Okay.
Wheels don't like side wheeling on a rotating.
Yeah, sure.
But,
Yeah.
this is like if you have a long part hanging out of a collet chuck like this.
Yeah.
This is a balanced steady rest. So you'd slap this on the magnet and then adjust the counterweight, and it just rides underneath.
Underneath it.
And it just gives it enough weight to balance the part and keep it from whipping around.
Interesting, but not below tolerance and push it and deflect it. Oh, that's cool.
There's a lot of playing with it to get it right, but it's pretty effective.
Huh.
So, I think Jared's actually running a grinder, so we can go see what's happening there.
And we're in a room just for dust control?
Dust control, kind of, the whole tool room's climate controlled to the same level, so it's not so much a problem, but just, it's nice to have a quiet environment when you're trying to touch off a grinding wheel.
Stay tuned, so I don't feel like
Yeah.
cranking it.
All day long. Cool.
You do enough little parts like that on the manual hand crank grinder, it's pretty nice to throw it on the hydraulic.
What's the hot pot for?
That's wax melt.
Fixturing with that?
What? Yeah. No, that's just so when we finish a carbide punch, we can just dip the tip, and then we don't have to worry about it getting chipped or damaged.
Oh, good.
Yeah, but
I would definitely try holding parts down with that.
It's cool.
What are you grinding on, Jared?
These are little blades. Side wheeling.
Jared's actually one of our apprentice instructors, so on top of doing this, he gets to teach people how to do this.
Cool. Look at that thin wheel.
So what we've got, it's about 3/16 wide, a little bit under, and it has 30 radii on either corner.
Okay.
So they want 30 rads down in the corner of this part.
Cool. And that's a punch?
This is a shroud limit finger.
Okay.
So, yeah, and so we've got a 4-place edge on there that they want held from the bottom. So I have a repeatable stop set up on my fixture.
Uh-huh.
And so we'll be able to do all 4 of these with a repeatable stop, go to the same number.
Got it.
So, yeah, kind of an interesting.
And this is the type of work that is sort of moving EDM over to EDM, or no?
Some of this would be done, like I could see people EDMing the cutout with the 30 thou rad,
Yeah.
but it's really pretty quick to do on a grinder, especially if you have quantity.
Right.
Like, you'll see how quickly you can just drop one of those in and sink the wheel down to the final
Got it.
depth. Nothing happens quickly on a wire EDM.
Oh, that's cool. Checking in on that. So you've got
Well,
that's
two
the
tenths.
flexure set up there, some gauge blocks to sets to give your
Yeah.
master.
Now, he actually had to go down to a fine tip on his indicator
Yeah, look
because
at
the
that.
standard ball wouldn't quite get on that ledge.
What you're trying to get on the
So he's trying to
On the
measure
little
this
ledge
ledge, and if you think about the size of a standard ball tip,
Right.
it would barely
Yeah.
fit in there.
that was a lesson that we learned is when you swap out those, they have to have the same length.
Yeah.
Once you know that, it's obvious, but you can't just go moving lengths and have the same measurement.
Yeah, and this.
It's a good way to fool somebody if you got a bad part, though.
Okay,
Yeah.
so it's zero there,
So
and
we zeroed
then
out there, and then it looks like we've got a couple of tenths.
a couple of tenths, yeah.
Yeah. Which
So you can see when it starts to ramp up, he's actually starting to get into that
into the
radius.
Sure. And you don't have much at all room to get on that ledge.
Yeah, hence the needle tip.
But that's fixture's reliable enough that you'll drop it back in and grind a couple more tenths off, and
right.
that's awesome.
And that's a tricky part too, because the up and down feed is graduated in tenths, but the back and forth sometimes can be a little bit tricky. But once you run a machine long enough, and it's just like any other machine, you get to know its qualities, and you can get it to, you can squeeze tenths off
Yeah.
if you need to. So.
The red gauge is your RPM?
Yeah,
Yes.
we put variable drives on all of our surface grinders to be able to tweak RPM. Gives you some attributes that you wouldn't normally have running at, like, say, a fixed 3,600 RPMs.
Sure.
So this one will actually go up. I think this is the only one we have that will go up to 6,000,
Yeah.
and the other ones we have limited to 3,600. So
Is that for service footage or for harmonics or?
You can get some heat out of a part. Like if you're struggling with a D2 part and you don't have coolant, turning the RPM down kind of helps with the heat
Sure.
buildup, and it also makes the wheel act a little softer. You can change how hard the
Oh.
wheel is depending on how much RPM you throw.
Huh.
yeah, like this wheel, I have it running 3,500-ish. Or I could run it up to 3,600 if I wanted to, because I have those forms on the corners, and to try to get those forms to hold up, because these are D2, it'll eat a wheel up pretty fast. So this will actually.
Got it.
By hardening the wheel, its form retains shape better.
Yeah, you want to avoid having to redress your rad
Yeah, no,
between
that-
grinds in
yeah.
the butt. Sure.
Sometimes you can rough stuff in, and then you go back and touch it up, and then put it right back down in again. You can clean it right up pretty nice. Taking out the fixture. Check out our indicator again.
No pressure, man.
That's awesome.
Yeah, it might be a little bit under because it probably put a little bit of heat in
Okay.
when we were going down. So,
Right.
but yeah, so we can just drop them in, plink, 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 and
Yeah.
away we go.
That's cool.
So,
Do you you have the clear view set up still? Just kind of
Yeah.
show them how that's done.
okay. So this clear view dresser, this is how I put the radii on the edge of the wheel. So the way this works is that it has a, I don't know if you can see it on there, it says 630.
Okay.
So
Yep. See the 630 right there?
So that's, we'll say your standard with the gauge block. If you would set the gauge block up to 630,
when you
would have a
rotate this
zero
to 90.
radius,
Okay.
right? So if
He's
a male
talking about
radius
from this surface to here.
from here to there.
Okay. Okay.
So if you want a male radius on the wheel, you subtract your radius from your 630, and it'll sink the diamond down farther. And if you want to put a female radius into the wheel, you obviously have it stick out longer. But that 630 is your guideline. So then you can just take a
600 even.
yeah, must be it there. So yeah, you can break this loose. Make sure you have a good clean surface there.
Oh, that's so easy.
Now Herman Schmidt sells it's like a verniated micrometer thimble, so you don't have to mess around with gauge blocks. But it's a Herman.
It's Herman Schmidt. It's not exactly. Yeah, that's slick though.
So-
and then you just rotate.
You can rotate. Yeah, it's got these locks on the sides. So if you want to stop at 0, you leave this one locked in, and then you can swing however far you want to go, and then it comes right back down to being flat again. But it actually has a little viewing window in there too, so you can actually really see.
Look at that.
What you're doing.
That's slick. So you look through that while you actually contact the wheel. That's cool.
Yeah, and so you can actually see how far you're feeding in, because that's the other thing. When I dress these wheels, I always go past 90 when I go, and then I'll lock it in like that, and then walk up the side of the wheel so you have point contact from your radius going up the side. Because if you would leave a full wall on the side, it can be too much contact area and it makes a lot of heat.
Yep.
So yeah, it's a really neat little setup.
And that's only going to grind the left edge or the right edge. So you have to find the side of your wheel.
Unless you want it in the center of the wheel and have a full radius all the way around. Yeah. So yeah, you do the one side and then lock it in and come over and find the other side and walk it in. So
cool.
Do you have your razor blade?
yes, I
So
do.
after he dresses the wheel, you want to confirm that your wheel is actually the radius that you want.
Yeah.
And some guys use graphite from an electrode burner. We use just a razor blade clamped in a block.
Okay.
And then it'll snicker the wheel through that. And then we'll go throw it on the optical comparator. And you can
sweet.
Check it.
And then you can
Yeah.
check the profile of the wheel using the razor blade.
Just a cheap hardened steel object. That's cool. Okay.
So yeah, there's a little step in there that's 1,000 smaller than the
Yeah.
razor blade, just so it has enough clamp to hold it in there.
Yep.
You can check it in the comparator.
This is really cool. Step into my comparator.
Yeah, this is the iron lung.
Look at that. Look at that.
So yeah, you can take it right up
Oh.
and set and check your.
So that screen on the comparator has radii built into the marks.
Yes.
Got it.
And then yeah, you can see how it fits right into the 30 radius.
Optical comparators, one of the most difficult things to film.
Yeah.
Yes.
Ooh, that's really cool. Yeah. Look at that. It's perfect. Do you know what the tick marks are of the demarcation? Are those tenths or
Well, it's
radius?
thousandths on up here,
Okay.
and then yeah, it'd be thousandths around here, but then obviously degrees going around the other direction.
Yeah, sure. Thousands, the major lines or the minor?
The minor lines.
Okay, the minor lines are thou. Okay.
Yes.
Got it. Very cool. That huge object is that little grind right there. That's cool.
Yeah, and this is a 50 power.
Oh, interesting. I think ours is a 10. 50 is a little bit unusual.
We can change it. We've got different lenses
Oh,
in
that's
there, but
slick.
Most generally, we use the 50 power.
Oh, that's awesome. Holy cow. I'd never seen one that has adjustable. Man,
It's really neat.
that's a really nice comparator. Thank you, I appreciate it.
Yep.
Have these grinders been rebuilt? Like,
Yeah, some of them have. The paint jobs aren't so stellar on them. That's just something that's really hard to keep nice on a grinder. But yeah, most of them have had some table work done on the reciprocating. What's common with these is some guys will put the, I think it's Rulon, whatever that. Yeah, they'll do that on the table surfaces, leave the saddles bare, and then that helps with how much effort you have to put into
Got
the
it.
wheel. I don't know if you guys cranked them, but to do that all day, every day, you build
yeah.
up some serious shoulder muscle.
Got it.
All right, we can go check out quality now.
Okay,
And,
sweet. So you said this is only one, you have two tool rooms though?
two.
Okay, interesting.
Well, we have a tool service department as well, what some people call a tool room. So basically, you're standing on a hollow floor right now.
Okay.
And so we have to be careful about how much machine weight we put on it. The edge of that building's kind of where the solid floor starts, and you can see the machine weight starts going up. But that's why we need equipment upstairs, but we have to, it just has to be lightweight mills. This is our quality lab. Brittany and
It's really
Frank, they're
quiet
working
in here.
here. Yeah.
Wow.
A couple things. If you look up the ceiling, it's actually a perforated ceiling, and it's an airdrop system. So air, when it has to kick on, it's dropping evenly from the entire surface of the ceiling.
Stop.
Yeah, and that really helps with thermal hotspots. And
The gradients of temperature.
You just get a solid
Really?
curtain of air down. But
Is that something that's commonly done and known in quality rooms?
a lot of this comes out of an area in Pennsylvania that's really big into high-speed stamping.
Okay.
And so a lot of shops over there kind of picked up these systems, and,
Cool.
and it just works. So
Sure.
why mess with it, I
Yeah.
guess.
Yeah.
But
It's kind of funny to think that quarter-inch holes in pegboard is the
Yeah.
key to the quality.
we keep it kind of dark in here because a lot of our measuring systems are optical based.
Uh-huh.
We'll turn a light on. Nothing's running. So. But yeah, so 2 video testers, Rockwell tester.
What's this guy?
That's just the control system for that. That's an older machine, but still pretty reliable.
Okay.
And then that one actually has a CMM probe for it.
Interesting.
That just magnetizes attached right here, our Shaw system. So we can do CMM probing on it if we need to.
Got it.
But
No, but it's funny because on the quantities you're doing, there's nothing close to 100% inspection, right?
well, we're doing some inline checks on
that right?
criticals. Yeah.
Interesting. In the presses.
Yeah.
Wow.
So, and we're doing that with vision systems
Yeah.
as well. So you'll see that a little later.
Cool.
But
Okay.
yeah, we'll get out of here. We also do a little force testing. We have 2 of these McMesson units. So something that's resistance welded, we need to ensure it's so strong. So this will literally, you put the part in and it'll literally rip it apart.
Tear apart.
We have one down in our plastics area as well, and it's the same thing. If it's an overmolded insert, it tries to cool down the plastic.
Ed and I were up at a place called Fabersonic last week, and they had they're a welding institute, so they had those, except they probably the 200-ton version.
Yeah, I saw that. It's like, oh, that's going to be like coming on stage after James Taylor or something.
No,
That's a pretty cool.
This is pretty cool.
All right, we'll check out the next tool room. So this is our tool service area. Laverne, he's one of our tool makers, and right now he's doing looks like a trial on a brand new die.
Okay.
So he has to inch that strip through each progression.
Yep.
So what's the progression on this? 400 thousandths? So he's got to get it through 400 thousandths at a time.
Look
and
at
then
all the tooling in there.
you see all the little carbide punches.
Wow.
Each one of those will come down and put a new feature in.
Sure. That's
And then when he gets it all the way through, it
proves
can
it out.
run at rate.
So this is just like a test
Yes.
press. Wow.
But yeah, this whole area is set up just to maintain, work on, and service dies.
Got it. What are the name? What do you call the bearings?
Those are
They have the
pins and
balls?
bushings, and when we call this part the ball cage.
Ball cage of
Yeah.
Penza bushing?
Pins and bushings.
Pens and bushings, got it.
But, and that's kind of a pretty common thing in dies. They all,
Yeah.
like something we call transfer die, which is a little cruder, a little bigger.
Yeah.
It might run on a bronze bushing.
Okay.
But anything we're doing at such a high cyclic rate, we really need to be on roller bearings. The new technology you're starting to see a lot, instead of a ball, it's best way to describe it is the profile is kind of like a W.
Okay.
And what that gives you is 2 points of contact on the pen,
Yeah.
and then on the other side of the W, 2 points of contact on the bushing. And that it's something like double the load capacity.
Yeah, sure.
I haven't really messed around with those too much, simply because we do a lot of smaller dies, but you're seeing more and more of those. Okay.
We maybe 5 years ago, I played around for a while with building my own ammunition draw dies, and
Okay.
most of that industry seems to use old Waterbury Farrell transfer presses, and they just keep rebuilding
Yeah.
them, retooling them, and
So lubrication is really important in a lot of this. Some of our newer systems we're actually fogging the lubricant onto the strip,
Okay.
so it's kind of like MQL for machining. Really cuts down on how much lubricant gets all over the tool. But so just kind of breaking it down, these are the bushings we talked about earlier,
Yeah.
the pins,
Yeah.
and the ball cages that
Oh, cool.
reciprocate.
can I touch that?
Yeah, a little greasy.
Yeah, sure.
And then this is a top hat. It's a separate part, and that limits the stroke of the ball cage.
What's up with the pin connector?
Okay, so he doesn't have it set up yet, but all of our dies have at least 2 types of sensors. Alright.
There's no risk of breaking one of those carbide things off because of the way those.
They're completely guided the entire
they're-
time.
got it.
So,
You've done this before.
all right. So this is a misfeed sensor, and if basically the strip comes into position and the hole in the strip isn't lined up, when the press cycles down, this will deflect up.
Right.
And that triggers the press to stop.
Got
So
it.
we just have the standard pin connector with all of our presses.
Got it.
Um,
I assume and hope that that's not common, but it's a good.
there's a lot of things that can go wrong. It's just kind of something every press operator deals with
Yeah.
on a routine. You know, just
But you want to make thousands of parts before you've got to stop
Yeah.
and tweak something, right?
Yeah.
Okay.
so as far as basic construction, this is the start end of the bottom shoe, and so this is what we call stock start.
Cool.
So you'll push this in,
Yeah.
and you'll feed the metal strip in, and then it'll come down and it'll put a pilot cut, which is just a round hole. And then when you release it, you can go forward to the next progression. And if we look, this is the pilot punch, and that next one is just what we call pilot.
Yeah.
And that locates that round hole then. Every time it inches forward, those tapered pilots will locate it.
The feed forward mechanism is outside of this. It's in the part of
on
the press.
this press, it's this big black contraption
Yeah.
on the rear.
Okay. So that's what you set in that case, like the 400
Yeah.
thou. You should be got it.
Yeah. Now sometimes it's pooling, it's a pool
Okay.
feed. Sometimes it's a push feed. Thinner foils will pool. It's a little more reliable. But
Cool. So you buy, tool steel for these big parts, these big blocks, and then you'll grind. I mean, there isn't a lot of machining here, right? It's a lot of grinding.
it's a
The
lot of
EDM?
grinding. So way this would start, we'd buy 4140 plates. I'd go down to our large Doosan on a magnet work holding.
Okay.
It would put in all the hole features, leaving 10-15 grind stock, even for soft, and then it'll get wet ground. We'll go through, jig grind the holes, and
cool.
that's about the end of that
Yep.
for the larger plates. Small plates, same thing. Instead of jig grinding, because of the contours, we'll wire EDM it.
Okay.
And but yeah, there can be some serious hours in some of these components just
Yeah.
because of the amount of grind work we do.
Do you only do this sort of work for parts you're running, or do you do this as a service for other folks that are standing?
We've done it for other folks, but again, it's one of those situations. It's really just key clients. It's not something we openly advertise.
Yeah.
Just because we need to have so much capacity on tap for us, we get into a big project. Timelines, 6 months sounds like a long time to build something, but when you look at the enormity of the project, we need everything we can get.
So these guys could be service ground, but you're moving them to EDM.
Yeah.
These are tall. What would you call that? You would call that a punch?
Yep, that's just a cutout punch.
Yep.
Now, as those dull, they'll get surface ground on the top and then shimmed up.
Yep. Oh, you have to shim it. Oh, they have to be coplanar.
So that they're always the same height when they
Wow.
come back. And the reason we do that is timing.
Okay.
We want these pilots to enter the strip, and then if there's a stripper, once the pilots are in
Okay.
and they locate the part, we want it clamped.
Yep.
And then right behind that clamping action, we want the cut to occur.
Got it. And so these cuts they're progressively cutting out more. You don't just stamp the
Yes.
feature in one. You almost sort of nibble it out.
So this is just kind of basically how it works. Starts out raw material,
Yeah.
and we'll put in some holes, and then it's guiding on those holes, and it starts cutting out shapes each time the strip inches
Yep.
forward, until eventually you just have a part.
That's it.
And then you knock the part through the die.
So even if the feed mechanism is off by a few thou, these will fix
Yes.
that. Okay.
Yeah. They'll
Subject to some
accommodate
amount.
for.
That's amazing. And so this is how Western civilization works.
Yeah.
Basically, this is high volume, cheap parts.
Yeah.
I shouldn't say that. Inexpensive. Sorry, competitively priced.
A lot of electrical connectors is how high-speed stamping is utilized.
Okay.
That's mostly what we do. When we say automotive and appliance, it's electrical connectors and contactors within those realms.
Got it. Okay, so you're not doing, windshield wiper brackets
We
or
do
stuff
a
like that.
little bit of that
Okay.
stuff, just a little. But bread and butter is electrical connectors. So if you've ever taken like a connector boot off on your car and looked
Yeah,
inside,
like a Molex style
there's
stuff.
like a little prong.
That's
That's
it.
that.
That's cool. So it's actually making little pieces of scrap.
Oh,
on
yeah.
Each, okay, yeah.
We'll go look at the scrap, and it kind
Okay.
of gives you a neat idea how it's all working. So that's what we call a connector die, and it's just more or less cutting, it might point the tips, whereas this is a little more involved. So this one's actually extruding
God.
down a foot and then flaring it.
Whoa. Okay, starting over there. Okay.
Yeah.
Wow. That's really cool. And it's running dual stations that are otherwise identical. So
Yes.
Dual, yeah.
So we call this a 2-out.
Okay.
It's an insert for overmolding application.
Okay.
And these are so it can't rotate within the plastic.
Got it.
And then the flare so it can't pull out.
Those are swedged in there, just pushed in.
They'll go into the mold and then they'll get injection molded
How do you
around.
make the groove? Like, you just push it in.
Yeah.
Yeah.
I believe it goes into a valve cover.
Okay.
The wires.
So this is the die coming apart.
This is
Now
amazing.
this is the stripper plate, and we
Okay.
got a couple varieties. So this one's mounted to the top shoe. Now that other die we were looking at, the strip more or less stays down, and then the punches go up and down. This one, because we have to bring it part up out of the cavity
Oh,
each time,
interesting.
these lifters pull the strip up and down.
Okay. The strip feeds through. No.
Yeah,
no.
you can see these little tiny grooves.
Yeah. Interesting. Okay, so these are actually, I don't know if the springs are too strong for me to push
Oh,
them.
yeah.
But yeah, okay. Yeah.
But yeah, the strip would ride through there, well, upside down. And yeah, then each
200
time the press cycles.
275 strokes a minute
Yeah,
for a second.
yeah.
Wow.
525.
Oh yeah, and it's a 2-out, so you're getting
Yeah.
double. That's insane. And so these collets collapse in. Oh, sorry.
What are we running? Is that 800?
800 strokes a minute.
So that's the 30-out tool, so it's making 24,000 parts a minute. The math of this industry gets really interesting when you start looking at stuff like that. And
How do you polish the rad on that?
so that one might be an insert. In that case, it's just a round, and that's carbide. We'll
Okay.
stick it in the lathe in a 5C collet, and then we'll use a ruby and kind of
Okay.
step over it, and then just diamond polish
You will.
and
Yeah.
felt bob.
Okay. Now you say it's an insert, but it's not coming out. It's not replaceable.
Oh, it's replaceable.
How do you
These
get it
are
out?
fully serviceable dies. We have parts in the cabinet. Anything in this can break, and we can just drop a new one in. And that's why the tolerances we hold in the grinding room are so important,
Got it.
because we don't have to fit anything. Everything is completely
Drop it.
replaceable.
I'm sorry. How does this? How that looks like it's pressed in there?
It's a light slip fit, I bet, and it's probably retained from the rear.
They're changing the rear with a head on it.
Got
Yeah.
it. Okay.
Okay.
Okay. Wow.
And then these, they're spring loaded, and this is what we call onion lance.
This is the beginning. It goes left to
Yeah.
right here. Yeah.
So if we look at the part, down by the end, you can see by drawing this bubble, it's actually kind of shrunk the diameter. You can see this gap?
Sure.
So to accommodate that, we put lances in, where it breaks the surface in a
Lets
couple
it-
spots, and it looks kind of like peels of an onion. And because it's only hooked on in those two spots now, it can contract.
Can move. Yeah.
Otherwise, it would wrinkle the strip tremendously.
So there's a huge amount of knowledge on the engineering side of
Yes.
how this metal is
Yeah, and
transformed.
there's a lot of rules of thumb.
Okay.
None of it's quite in a book, and different companies have different rules of thumb.
Yeah.
But
I don't know if it comes through on the camera, but the quality of this is amazing. And the
So-
fact that this has been beat up. I mean, it has been punched.
how many millions it is?
Yeah.
I'm not exactly sure on this one. I have to look at the service work order, but it's probably around 50 million or so.
50 million hits.
Yeah.
We have a few that have 100 million.
So that's 100 million parts for 50 million hits.
Yep.
But so on the top end of the shoe, these are the stripper plates, and these do two things. When the part is pushed down, the surface of the plate will actually clamp the part.
Yeah.
But then, more importantly, and where it gets its name, when the punches come up, it stays down because it's spring loaded. It strips the material off the punch. But so all the punches then will have a tenth per side to 50 millionths per side guidance through that plate, and that's what locates it to the bottom. Since the stripper is located to the bottom shoe with the ball cages, it just all lines up for us. then.
That's amazing. Wow. Yeah, and the design of this means that it isn't that hard to align the die set because the way it's
There is no aligning.
Yeah, it just goes in.
These we send out to a larger jig grinder, and things just get put together and work.
That's
So,
cool. Wow.
That's like when I said back to transfer dies. That's where you see a lot of guys with indicators
Yeah.
and tapping things around and then drilling and reaming things onto location. We don't have to do any of that.
Yeah. Well, and the consequences are catastrophic.
Well, that's the other thing is it takes a lot of human error out of the equation when everything's standardized to just various parts. Now let's go look at some of the die components we put into these.
Whoa.
That's an insert for the bus bar that we run out on the production floor. If you look at this
Oh my
closely,
God.
there's tiny, tiny dimples in it.
Yeah.
They're 2,000s deep, and we have to form 30 of those dimples in 30 parts every time the press goes up and down. So
Those are actually part of the feature of the part. Wow.
Yeah.
Oh my God.
that's all done wire machine.
That's a sinker then? Or no, wire.
The dimples would be synced.
The sink. Okay, yeah.
And we don't do sinking in house. We just don't have enough of it.
Got it.
What else you got?
Here's that same machine now. He's pulled the die set. You call it a die set?
Yeah.
Okay. That's awesome.
So for this machine, we're just using, forget what brand clamps these are, but that just holds the shoe top. But for all of our production machines, they're on a base, and they just down to location and then two screws.
Just tighten it.
Really quick setups then, and
It's awesome. Because you're never leaving this. A press doesn't say set up for a year
No,
per
no,
part.
no.
It's
we might
changed
see,
over.
what, 2-3 die changes in a day some days?
In a day.
That's a smaller press. The
Yeah.
big press it'll run a week max.
A week
maybe
and then
2
change
3
over.
days.
Wow.
2 shifts a day.
You guys run 3 shifts?
Two tens.
That's a big forming punch that we have.
Whoa. And that has a ejector? What's the...
That's a vent hole for when
Okay.
you're
Yeah.
pouring, so when your punch draws back out, it doesn't create a vacuum.
Oh, interesting.
It'll actually pull the bottom of the cup up if you don't have that vacuum.
Got it.
Pull in.
And that's carbide?
Yes, Carbide. This is not the mating insert. It's
Okay.
from the same die,
Okay.
but there you can see what the bottom looks like where we're forming into.
Yeah.
Actually, that might be the mating one.
I don't want to...
You're going in there. with
Okay,
that,
got it.
form the cup.
Yep. That's awesome.
So these are like
Whoa.
my favorite example of a punch and a die.
Yeah.
Just the size of them. So these are powdered metal, and
Okay.
then we're sending them out now for surface coating. The balls are, so this is similar to what you have on end mills.
Yeah, like a TIN.
Yeah, and it's a lot cheaper than going carbide. Obviously, just the something this big when you're paying carbide by the weight,
Yep.
really adds up. But so this is a good example of punch to die clearance. So the material is so thick that actually looks like a pretty sloppy gap.
Sure.
But we need that amount of clearance in order for it to work. Now, once the material gets thin, that gap can go down to 2/10.
Yeah.
But this is 3 millimeter thick material, I think.
But that's shearing. That is...
Yeah.
Now, is the bottom of that perfectly perpendicular to this, or is that an angle so when it cuts,
We
it slightly cuts?
generally don't, we call that like a rooftop or a shear angle.
Yeah.
That affects part flatness.
So you don't do it.
Generally not, unless we're just getting rid of metal around the part.
Okay.
But yeah, a shear
Oh my
angle
God,
will
that's
reduce
really
tonnage.
thick. Wow.
That's actually a variable valve timing part for a Jaguar, I believe.
It's a variable valve timing part for Jaguar. Cool. That's incredibly thick for that kind of clearance. We've seen this just when we set up a little punch press.
Yeah.
You punch a 3/8 inch hole and you see the clearance you got in. That's cool. Look at the plate that's coming out. Can this come off of a roll?
Yes. Oh,
Wow.
yeah. This just comes in about 3,000 pound coils.
That's awesome. Now this has to go at a slower stroke per minute because it's thicker.
150 strokes a minute.
150 still?
Yeah, so it'd be 300 parts per minute.
Our slowest press can only run 125 strokes a minute.
That's as slow as it goes?
125 or 100.
Yeah, that's as slow as it'll run.
Wow.
So
And what's the other? What's the fastest?
fastest, we don't run it that fast, but it can go 2,000, can it?
No,
1,500? Okay,
per minute.
per minute. So we're currently running it at
That's
800.
significantly faster than most machine guns.
Yeah.
No, seriously.
Yeah.
That's incredible.
So at 800 inches a minute, it just kind of starts to have motion blur,
Yeah.
and
right.
it's pretty neat to watch.
It's like persistence of vision as you're.
Yeah.
I've actually been to Bruderer up in New Jersey where they build these presses.
Yeah.
They have in their showroom. They actually had a press running at 2,300.
And it's just kind of a.
Yeah.
You don't
What's
hear
the up and down motion driven by on these?
It's an eccentric cam.
Okay, it
generally.
is cam. Okay.
Yeah.
Wow. That's cool. Did you grow up in this world? Did you know about?
I was always a machinist. Last place I worked, I became a tool and die maker. And that was a lot for tire industry and the can tool industry, both of which Canton's really popular for. This is called a pancake reel. Pancake reel. Feed off of that, and then when it starts to catch up with the press, it'll trigger. And then you see how it bumps off those two leads?
Yeah. So that'll tell it to feed more, and that'll tell it to slow down.
Yeah.
And that's done electronically, not by pushing it, but by just contacting it.
Yeah.
Okay.
Grounded. So this is the actual stamping press, and it's running 800 cycles a minute.
Adam, that's amazing. pulling the strip through.
Yeah, and it's clear top. It's kind of neat to watch. You can- All these presses are on moon shoes. They're all on springs. So the bigger one you'll see is actually bouncing up and down. And if you look at how top heavy it is and the spindly little legs, it really makes me nervous.
Oh my God. Those are great. The noise taper.
It's impressive. All right, so now we have 24,000 parts a minute that we have to do something with. Right. So you know how I said earlier we do a lot of in-process inspection?
Yeah,
That's a camera system.
that's what that light is.
Yeah.
Okay, Julie, so that light there is that.
So out of there, it starts to go into our reeling system. And this is what makes it all work. This is an accumulator. So, Travis, you mind stopping a reel? So when that reel gets full, he needs to swap it. He can bring this reeling spindle to a halt.
Oh my
And what
God.
happens is this starts to go up,
Start going up.
and accumulate the length of the part.
Where did that go?
Each one of these is on an independent bearing to make it work. So we just spent days making these dumb plastic little things. But the reels, the way they work is they just drop in. We have these quick change hubs, and you just drop them into the reeler.
Yeah, it's like a bicycle.
Yeah. So there's actually a lot of fuss over how smooth we need to have that drum wound. So you can't hardly see it, but they're oscillating back and forth. And if you look on top, there's 5 ball screw stages that are oscillating it. And then the whole thing's servo controlled. There's 11 servos in the entire system.
Can I step on this?
Sure. Man,
Oh yeah. Hey, you can see that moving left to right.
so this is where we do more of our heavy machining, where we have our 2 machining centers.
I don't think Ed has ever seen a more jig grinder in person.
I've seen one.
Okay,
Okay. We have a Doosan, and it's 52 by 26, I think, and then we have a 30 by 15 Mori.
Yep.
Both are pretty good machines. Like both.
And
we have a
look at
large
that.
Chevalier wet grinder.
Look at that grinder. It's 2460.
Yeah. And we max it out on occasion.
Holy cow.
So right now he's actually making a fixture plate. It'll have 276 holes in it, reamed and tapped in the bottom.
Whoa, look at that. Yeah, this is a nice size machine.
Yeah, and that entire thing's being held by magnet.
Yeah, I can see that. That's cool.
That's 50 taper, big plus. Really nice machine for the type of work we do with it. Since we're not shooting for ultra precision or die contouring or high speed work,
Right.
we just want nice, big, heavy cuts.
Right. I can't get over the size of this grinder. Well, I just saw Okamoto. I think it was probably a 2470 or so, very similar though. It was a column, so they were, unlike the smaller ones that are saddles where the table is not supported at the
Yeah.
far extreme. I think this style would be
Okay.
supported. Really cool.
The stops are nice on that.
Say again?
I like the stops on that.
Don't really use them much. This is a CNC controlled machine, which,
Oh, wow.
given the preference, if I were buying a wet grinder, I think I would splurge for CNC versus
Yeah.
a hydraulic,
Even if you're just doing flat grind?
simply because you can punch in dressing cycles, and
Yeah.
it allows you to walk away from it so much longer.
Yeah.
Like when they start wet grinding these, the amount of time they'll spend at the machine is going to be minimal.
Just
like
set up and go.
15 minutes to get it running, and then just
Yeah.
let it do its thing.
Now, when you say wet grinding, I mean, you run that 1224 with coolant.
Yeah. We
just-
just any big grinder that it's not a Parker Majestic, we call a wet grinder.
Got it. That's fine.
Just kind
Just
of
making sure I
internal
wasn't missing something.
thing. Yeah. All right, we can go over the jig grinder.
So can you explain, because I certainly didn't know much about more jig grinders, and probably still don't, but can you explain to folks, more the importance of the company, more in the world of precision tools and machine tools? And
Moore is responsible for the 4th decimal place, is what I was always told.
it's awesome.
I don't know if he was an engineer for Bridgeport or just in that area, but he saw the need for a higher precision machine, so he developed the jig borer.
Yep.
And then in the 40s and 50s, he wanted to get into being able to do high precision work to harden components. And so he took the frame of the jig borer and applied a planetary grinding head.
Planetary grinding. Yeah. So okay.
So the best way to describe it is planetary grinding. So you have basically what's a air spindle,
okay.
but it orbits.
Yeah.
And it's more or less mounted to a boring head style action, but it's controllable up here.
Yep. That's
So,
that's the diameter or radius of what
Every 10th I move up here, the wheel moves a 10th farther from the center line of the spindle. And that's how you take material out of the bore.
It's almost like a dynamic or a live boring head where you can just adjust it while it's rotating, I assume?
Yep.
Yeah.
Yep. And there's also angular tilt, and that's more to adjust tram than it is to make features.
Okay.
It does go up to 1/2 degree either way.
Okay.
But some die components, after it cuts, there will be an angle. And so some shops do grind those angles in that way. But for us, it's almost always set. But if you start to notice you're getting like a little bell mount on the end, or you start to see a little taper, you can tweak it in up here. Just a little vernier. But
So this looks like what you just posted on your Instagram for the Autodesk Cam
very
Challenge.
similar.
Okay.
So this is an electroplated cubic boron nitride wheel.
Okay.
So there's a single layer of diamond, or
Okay.
cubic boron nitride, a single layer of abrasive.
Yep.
And once that's consumed, it just is bare steel underneath. It'll rip off, and then that wheel's done. So I do most of my roughing with those because they're really economical.
Okay.
It's a cheap wheel. You can get a lot of life out of it. I probably
When
had
you
this
say
one for
cheap.
2 years, $50.
Okay. 2 years.
Yeah.
Oh wow. Okay.
Now we don't. This runs once, twice a month, but I mean,
Okay.
it's done a lot of work.
Okay.
The nice thing is you don't have to dress them. You just throw them in. You can start roughing, and really, that's
Not
not
bad.
a terrible finish.
No.
I've seen boring heads give worse, but once I go for my finish pass,
That is a straight wall.
Yeah.
It's hard to see in the setup. Sorry.
yeah.
Okay.
Once I go to my finish pass, I'll put a sand wheel in and dress it, and
So where do
this
you
is a
dress it?
60 grit, and then that'll give me a phenomenal finish.
Where do you dress it?
So we have 2 options. You can put a diamond in this,
Okay.
and then mag it to the table or your part.
Yeah.
And this is actually a screw thread.
Oh,
So
stop.
I can approach it,
That's genius.
and it just worms
my
on
God.
the.
And that doesn't even have it. Just
No,
works.
it just worms on the magnetism.
Oh my God, I love that.
And so you can get it real close to the wheel,
Right.
and then once you make contact, you infeed up here,
Okay.
and then you use the machine stroke to
come
press.
up, okay.
The other option, this is how Moore recommended doing it, is you just have a block with a diamond nib, and you just pinch it and hold it. And I do that if I'm in a hurry sometimes. You just get real good at putting the pressure in the dead middle of the
You
block.
hold it?
Yeah,
Stop.
yeah, and it's effective. It's a little scary, but it's effective.
Oh my God. Well, these things, the spindles are like 30,000 RPMs.
This is a 40,000.
40,000.
This is my 8,000. This sucks. It has no power. This is a
Okay.
1/4 horsepower, where this is a half.
Okay.
You can literally grab this, bring it to a dead stop.
Okay.
No damage to your hand. But what it does do is allows you to run real long grinding shafts.
Oh, okay.
Where this being a 3/8 shank, I'm already starting to see deflection at this length.
Okay.
So when I go to finish, I'll
Even on like a spark out? Like,
it's going to be challenging with that amount of length. So I'll probably have to switch to this one with a rigid shank.
Got it.
So that's how dressing's done. Those come on those
It's a joke.
Goering taps.
Yeah.
And we had a German apprentice here. Well, a couple of them actually.
Okay.
Needle slapped stuff on.
These are definitely made in the U.S.
Yeah.
The book that we talked about, that we learned about from Richard King's scraping class, which is called
Foundations of Mechanical Accuracy.
You can still buy it new from the Moore Company. That's like $150, but absolutely worth it. Don't spend the $800 for the eBay ripoff post-market sale. And that is this company. I mean, like you said, they really laid the groundwork.
Yeah, the guy who trained me on this made me buy that book, and then their other one, Holes, Contours, and Surfaces.
Okay.
And he made me, kind of get familiar on book. So the other thing you could do with these, besides holes, is contours and surfaces. And the way that works, let's say I wanted to grind down this wall,
Okay.
and then put a radius on it,
Sure.
and then grind down this wall. The way that would work is I'd orient my spindle
Oh, look at that.
to the grind side,
Okay.
and so you actually have a rotational
of that.
axis, and you'd rotate it too, and then your spindle would just oscillate up and down as you grind along, and that up and
You
down
hand feed
motion.
your X.
Yeah.
Okay.
And that up and down motion is what gives you a really smooth finish, because you're kind of averaging out the high spots on your wheel.
Sure. Can you turn it on? You mind?
Yeah.
Yeah, that's it.
So this is at 80 psi. It goes up to 100. 100 would be 40K, and it
Okay.
scales down. So at 80, I think it's like 32,000 RPMs. Takes a little while to get up to speed.
So there's just veins inside of that.
Yeah, and all the air ejects out the bottom.
It's
and that
natural
keeps your-
tube evacuation.
Yeah, that keeps your part cool. That being said, the CBN wheels, they're very open. I don't know if you saw how coarse it was. This won't hardly get any heat into it, like a few degrees at most.
Can you turn it on? Can
Yeah.
you turn the boring feature on?
So that's the rotation.
That's awesome. Woo! Oh my god, that's scary.
So once they're in, I'll spark out.
Oh, it's cutting. You okay with that?
Yep. Slow her down.
You're hearing it bog down, or just the
What?
Am I hearing it bog down, or just the change of the cut?
It probably bogged down a little.
And you set your travel limits in Z.
Yeah, ideally your wheel's not supposed to come off the bore.
Okay. And you're doing this to chase not even tenths. I mean, maybe even less than a tenth
On a shoe, I have a 10th window generally I'm trying to hit.
total,
Yeah.
plus or minus 50 million. I like how too they're like the whole machine is built around longevity with the covers
Yeah.
and the protection.
It doesn't do that great. You still got to get under there and scrub every once in a while. But,
Has this been rescraped?
what?
Has this been rescraped, or is it?
No, this is original.
Okay,
These,
yeah. I noticed
from
the,
the factory, these aren't scraped. These are lapped ways.
Oh wow.
Okay.
And what's really cool about the Moore is at no point is the load on the table ever outside of these pillars. Like the entire width of it is always bearing down through these pillars into the floor. And so you don't have any table sag like you
Which
would
is
on a bridge
overbuilt,
board.
right? I mean, you have
Oh, yeah.
very little X travel relative to the width of the pillars.
So these are your guidance, and then these are your support. And then when you get on location, this
Lock
is a
it.
lock that sets.
Does it move when you lock it?
Sometimes, yeah. You'll see 50 millionths. But they want to come out and recondition it, but I mean, it was an astronomical number. And so you just kind of learn to stay short, lock it, and watch it jump in onto location.
And with having lapped surfaces, wouldn't there be more stiction or stick slip?
It's not bad. I'll
Yeah?
knock it. You can-
Yeah, where you would
Now,
think flake.
that being said, the later models did have a bearing cage of flat cylindrical bearings. And these
Interesting.
rode on bearings
Really?
on this part.
And yours, that's
So
no
I mean,
longer
that's how you could. It's a very smooth
Oh,
machine.
no, that's not bad at all.
But
Now, because we have a DRO, you're okay. Otherwise, that would have been
Yeah.
bad.
That being said, we do inspect the DRO and the ball screws. Well, I'm sorry, they're regular screws, and they're very true to one another. Come on.
That's
Yeah.
cool.
Yeah, I noticed a little of that more pattern scraping up here.
Yeah.
See if you can get that, the hooks.
Yeah. Do you know what year this machine is?
83.
Oh, okay, not that old.
Yeah. And
Very special.
this is a G18. So originally you had the 1, 2, and 3.
Okay.
And the G18, they got rid of the smaller ones because nobody was buying them. And they just really improved the number 3.
Got it. So the number 3 became the G18.
More or less.
Got it.
And you see them kind of misidentified a lot.
Interesting.
But some neat things about it, like this is an in-bar spindle. And
Okay.
it's actually held hot. It's at 82 degrees constantly.
They keep it that way.
Yeah.
Oh.
And so once it comes up to temperature with the bearings, the thermostat will kick off the heater. The only problem with the in-bar spindle housing is it's so soft, it'll actually start to wear. And older ones of these, the V-way will wear enough that you'll see some sag, and that'll affect your tram.
Sure.
And they have to spot that in. But the whole thing's counterbalanced. There's a chain here,
Oh, okay.
and that's so when you release the spindle, it rolls up nicely.
Is that a drawbar of some kind? Or is that your Z?
No, this is just the main planetary servo motor. That's what rotates the.
Rotate, not your
yeah.
spindle, but the orbiting.
Yeah.
Okay,
Yeah.
I'm with you.
And you can kick that into neutral if you're doing fine indicating. But
Got it. Such a cool machine.
yeah, a lot of this is going away. Wire EDM is just kind of reigning supreme these days. And even a lot of VMCs, a lot of die shops are single point boring their shoes, and it's acceptable. It's perfectly fine.
There's a lot of skilled labor in
You just don't find a lot of people that have had experience on them. And a lot of the stuff about them isn't a set parameter. So it's not a good process that you could drum somebody in.
Yeah.
So this is like a knob, 1 to 10 for the rotational speed.
Yeah.
And so you're just always kind of like eyeballing it. This is the down feed, and the entire thing is like 0 to 1. That's your setting for
funny.
feed. And so it's a very hard thing to like write down parameters and have somebody go and pick those parameters up and make a part with.
Cool.
And then we have the trimmings. We got the rotary table, parallels, and
Oh yeah, look at that.
Even this is made by Moore.
yeah, these things to buy new are like $200, and a lot of guys will get the Indicals. But once you use them, you really realize more like the flexure joints are very held tight, and it's a great little indicator holder.
It's funny.
But,
It's like the Herman Schmidt of America.
yeah. But the Moore table it's not to this machine originally. It wasn't like a set, so it's a lot older, and it's got some age on it.
I think I've never seen one with a plate built into it like that.
Yeah.
That's cool.
Got some weight to her.
That handle is very deceiving. First time I encountered one, I was like, I'll just pick this up, and I'm pretty sure I shrunk a ½ inch.
Nope. Well, I don't think these things are light either.
No, and they're very top heavy, and if you look how narrow they are, they're very scary to move.
Yeah.
Is that the
I actually love these
old
older
Fanuc
machines.
control?
Scott, can you get a peek what you're working on? You're just squaring up a block.
Yeah. Cool. Old school Mori. Awesome.
Then another Bridgeport hiding in the corner. So a lot of what these guys do down here also is upstairs we do all the die making, downstairs they do all the mold making.
Okay. Injection molding.
Yeah.
Got it.
So Scott, and you'll meet Steve, they're both journeyman mold makers,
Okay.
whereas upstairs everyone's a journeyman die maker. All right, so this is very temporary, but this is our wire EDM room. We have a enclosure a staircase getting made. Like this just got set up, so we're still kind of piecing everything
Kind
together.
of a strange location for a wire EDM, or for any machine.
But
here.
if you think about it, it's separated from the production floor for vibration.
Okay.
So even the molding department, there's some vibration in the floor.
Sure.
It's very thermally isolated because we have building on all 4 sides
Okay.
and the ceiling. There's a building above us.
Okay.
So
Wow.
from those two perspectives, it made some sense. But yeah, it was a little
Kind of funny. You got,
unconventional choice putting
Right.
it 6 feet up off the
was
ground.
this a storage room before?
It is a crawl space.
Yeah. You hear that, Grimsmo? You can put EDMs in your crawl space. If you guys haven't seen a wire EDM, card here to the video at Nicholas Hackle Watchmaker in Sydney, Australia. They had just gotten their wire EDM and we're learning to set it up as well. Really cool. There's the wire.
So for the tooling set on this, the guy kind of doing the procurement, he chose Hirschman, which same vein as System 3R and Arova.
Okay.
But so this is a leveling head, so he could stick his part clamped lightly in this leveling head, and then
Oh, interesting.
use these jack screws to tilt and gnaw it.
Huh.
And so if you have something that's not necessarily precision ground surface, like say it's just machined and it has a 5/10 out of parallel or
Yeah,
something,
sure.
you can dial that right in,
Just
no
go.
problem.
That's not something I've seen on System 3R and Aroa, although I don't.
They make them,
Okay.
and then on top of that, you don't have to necessarily have the part in straight to X and Y. You can just probe and go.
Got it.
It can be on an angle.
Right, because you can use the wire on these to probe.
Yes.
That is so cool.
So yeah, grabs the wire, runs it through, anneals it, drops it down through, threads it into the lower.
Does that all automatically?
Yeah.
Yeah.
Say it anneals it.
Yeah, it anneals it to straighten it a little, but it doesn't do that during production. Now this machine also has a wire chopper on it. So
The wire.
after the wire is consumed,
Oh, he doesn't just dump it into a huge bucket. It cuts it up.
Yeah.
That's actually really nice. I've seen some wire EDMs that were overflowing. Yeah.
that being said, it's kind of noisy. So if he's in the room running it, programming, he'll turn it off and then just grab the bale of wire.
Yeah.
But overnight, yeah, he lets it chop away.
Yeah, overnight, because you'll have some double-digit hour cycle times
Yeah.
on these things. So this is new, but you were already started making some parts with it?
Yeah. We're already making a lot of our machine build parts. We're making a contraption.
Okay.
We're doing that because typically it's a little less demanding than true tool and die work. So once Steve gets comfortable with the machine and how to do everything he needs to do on it, we'll move into our punch and die spares, which is what the machine was bought for.
To make spares.
So those cabinets you looked up at up there, that's about $600,000 worth of tools. And so just being able to have all that in-house and be able to do it ourselves,
Yep.
just saves a tremendous amount of work and
Yep.
money. Every shop that has a wire EDM has something like that.
No! Oh my God, folks. Ed, do that. That's amazing. Oh my God. I gotta figure out how to get one of those things. That's amazing.
And that's actually 3/10 clearance between parts.
Yeah, it's a fair amount.
Yeah, it's actually kind of loose. The trick is to grind after. Yeah,
Oh, you grind the face afterward.
Yeah.
Got it.
and that's the illusion really.
And this is the question. Yeah, so there are 4 separate pieces. The
Yeah.
kerf. Well, actually, they make some like 50 millionths kerf
Yeah.
wire, I think. But that's 5 thou?
No, right now he's got 10 in it, and I think this
Okay.
one goes down to 2 or 4.
I love it.
That's a drop. So he was cutting a gear with a key in it, and after he cut the gear, that's what's left over. Actually,
You cut a taper right in the bore too. That's
here you go.
Oh my God.
So that came out of the center of that.
That's got to be like a 20-hour cut time.
And then
You don't have to use your old Bridgeport approach, Ed.
we actually made a gear out of a bigger gear. You can it gives you a sense of how he approached it. So,
Look at that. Right.
yep, tapered bore. So,
I love it. This is cool.
but yeah, this is more of the Hirschman components. So this is just one of the rails. So if you had a plate, you can span 2 rails, and then adjustment screws on each quarter, so you can
Dial it
get
in.
the flatness dialed in.
Cool. Have you ever run it?
Me? No.
Yeah.
Kind of one-man band up here.
Got it.
But So this is their linear motor machine.
Oh,
But we felt if we're going to buy one, let's get the linear motors just because it gives you that extra bit of longevity.
okay.
And if there's a application for linear motors, it's wire EDM. There's hardly any force, and so.
There's no issue with the heat buildup, I guess, but you also don't need the speed.
There's two types of linear motors, and I'm not super read up on them, but I think iron core are the ones that generate more heat.
Okay.
And like I said, not real read up on them, but the ones they apply to wire EDMs and some grinders, they don't have nearly the force, but they also have
Not the heat.
barely any heat.
Got it.
Is there any kind of hydrostatic waves going on in here?
No, you can actually see it's just on regular.
Yeah, I saw those up
Yeah,
top. Little covers on them.
yeah.
The fact that they run in the liquid, they always look so clean and.
Yeah. Well, when you cut carbide, it actually turns kind of orange.
Oh really?
Yeah, I don't know what it
crust.
is in the carbide. Maybe cobalt or one of the binder materials, but it looks kind of like a big orange juice vat. So, right now they're just doing all the programming on control. You can import DWGs right into the control, and he hates it, but it's for the what we call fourth axis cut where it has taper.
Yep.
I guess it's really limited.
Yeah, the way it handles taper is it just changes the two head positions, just runs the wire like,
Yeah.
again, like art school class where you tip
Yep.
your wire in the polystyrene to.
Yeah, so the bottom head will move independently of the top, and that's how you set your angle of your wire.
Cool.
They go in a steering column assembly so they can line everything up. They don't use them after that.
It's just an alignment jig.
Yep.
Yep,
Interesting.
one-time use.
Yep.
And, little teeth inside of it.
Look at that.
Line 'em up.
It's a pretty cool. Like I can't. Where's the part line? How's that molded? Left to right?
Yes, we have there's slides that come together.
Oh my god.
You running this one?
That's awesome. Yeah, so the mold closes, and then there's an auger or a screw that's just pushing in the plastic pellets from there, compressing it in the mold. It's got to stay closed to cool it down, solidify. There's cooling lines, the blue lines right there through it, and we'll see it open up here in a minute and spit out the part. Again, basically how Western civilization runs. And the parts are going down there?
Yep.
Truck cap parts.
Yeah?
Yeah. This one's not currently running, but basically we stamp and then plate a strip,
Amazing.
and then up there it comes
yeah.
off a reel.
The
And there's a
product
feed
you
system.
made.
Yeah.
Yeah, right.
And
So
that
you
feed
got to
system-
get this to just feed straight from the machine
Yeah.
upstairs, coming straight into the injection. Okay.
We actually had one where, and thank goodness the program's done because it was a nightmare. It was stamping in the mold.
In here.
Yeah.
Oh.
And we had to have, because it's horizontal, we had to have vacuum to evacuate the chips.
Yeah.
And
Yeah.
that was not a pleasant part. But yeah, so just stamping out electrical connector and then overmolding plastic onto it.
Yeah, look at that. That's cool.
And then when it gets into here, this will blank the part off the strip.
Got it. So
And it's doing a little video inspection in line.
I love that. That's awesome. So yeah, you're really not kidding. There is a form of 100% inspection.
Yeah.
It'll catch.
This Van Doren has like a toggle lock on it, like a Luger.
Yeah. Think about the force of that.
These are just a screw cap.
Oh yeah, that's right.
Just a hex-headed screw goes in there and it covers it.
Yeah, how many linkages are in that? Oh, awesome. Now there were white pellets in the hopper, but the part's coming out black.
There's color in the material to turn them black.
Say again?
There's color in the material to turn them black.
Interesting.
So this is the owner of the company, John Miller. John
Hey,
Miller, John Saunders.
Good to meet you.
Good to meet you. Hi, I'm
Ed.
Thanks for having us.
So this is a shuttle press.
Shuttle
So the way a
press.
shuttle press works is you have one top half of the mold and then two bottoms. So Y1 is during its mold cycle, you're loading another part to get overmolded. And it keeps the operator always doing something, essentially.
So for overmolding, you say?
Yeah, anytime where you're having to put something into the mold cavity, and there's that part changeover time that can slow down the operation. It's kind of like a HMT, same concept. You're changing parts while it's cutting.
It's also vertical, right? So you have the gravity to set your part in the...
Yeah.
I'm assuming that this goes in that...
Overmolding in a horizontal press, we've done it, but it's tricky.
Different.
You have to have some way of holding the part in.
Right.
So.
Cool.
All right.
Thank you.
Hey,
Appreciate it.
anytime.
The floor, the room where we actually saw the, what do you call them, Bihlen?
What?
The Bihlen.
Bihler.
Bihler, excuse me. That is a solid floor, or that's the second floor? Is there a basement below that?
No, that's all solid
Okay.
floor. Yeah, when you come up, just take a peek, and
I
you'll
would think
kind
it
of.
would have to be,
Yeah.
given the...
Believe it or not, though, like the stamping presses, the Bruderers, they don't require more than 6 inches of concrete. I was telling Ed, they're on springs.
Oh, yeah, okay.
And so we'll see the big one running, and it'll kind of make you nervous to be around.
Okay.
Because it's a 55,000 pound machine whose the bulk of the weight is above the halfway line.
Oh my God.
And it's on springs bouncing around. So it's really
It's a
uncomfortable.
pogo stick.
Yeah.
Yeah, that Doosan is you can see the tool changer. I mean, that's a big,
Yeah.
50 taper?
50 taper takes up a lot of spacing compared to 40.
still working that fixture plate?
Oh yeah, he's gonna have to do a lot of work. He's got the underneath side done.
Yeah.
You can feel the holes, but
Oh, I see. Yep, got it.
so the way these two will work is, you see this 3-inch wide groove?
Yeah.
It's actually 3-inch 5/10 to 3-inch and a thou, and then that plate will get ground 3-inch, and then they'll T junction, and then there'll be a buttress in there as well. But for relatively cheaply, you can make a really rigid machine frame.
Got it.
And I say relatively cheaply because 3-inch plates of 4140 are expensive, but
Yeah.
but I mean, compared to having a weldment made and having it stress relieved and ground, this is a really, really good system. And you'll see a lot of examples of that up in the assembly.
You guys run this machine often?
It's one of those things that might run 2-3 days a week and then
Okay.
sit for a couple.
Got it.
Our work comes in like waves. We'll release a package of drawings. Go ahead.
Cheers.
And you'll see like a bunch of milling work getting done for a couple weeks, and then a bunch of grinding work and a bunch of assembly. John gets you some stats. Just the amount of material weight we move in and out of here every week is mind-numbing. Three out. 3 parts per head.
they clean them. That's a screw cleaner, and they come out clean, and then this is a weigh scale. Can I touch them?
No, I think 20,000 it'll release, and then the next one will slide in. That's how they go to the customer. The maintenance guy the other day got an evacuation hood. He's actually there's the strip. So that's a material straightener. When it comes off the roll, it has some camber in it, and that'll straighten the material out so it doesn't blow in the die.
And you can really see it moving. For different materials, you get different lubricants.
So we're bolt feeding rivets.
So pancake material roll, that straightens the material out so it's not any curve or camber. Sensor, slack loop.
Leaf spring for a heater contact. So when it gets so hot, it'll take. What the strip looks like. It puts pilots in these dimples in and notches, cuts, and then it pushes the part through, and then it cuts the scrap.
Stuff's really coming out of there.
I'm currently trying to get rid of that thing. We're working on those plates. It's the frame to replace that.
Ed, I've got one of those. It's sitting behind my desk. The little in-feed. That's when we were trying to work on the ammunition.
That's an air feeder.
I've got one.
Well, this is a Bihler machine, and it's a base plate, and then you can attach cam outputs anywhere there's a black surface.
Oh my god.
And feeds into the first station, which is a die.
Wait, it goes right to left. That's so weird.
Tell me about it.
I don't like that at all.
So, first thing that's happening, this is silver.
Oh, wow.
And we're welding that silver coated contact
In this.
in
No
this.
way.
And so, yeah, this is a turbo powered welder. That turbo slide pushes it down.
Sorry. Light curtain?
Yeah.
That's what we call a light curtain. Sorry.
So, in one motion, it cuts off of this, places it down, and then resistance welds it.
Yeah.
It goes through the die, and you can kind of see the contact on it.
Yep.
It's happy. 300 milliseconds. God, that's amazing. Just some of the scrap we make. We do aluminum, steel, and stainless steel. Do a little bit of brass, but not a ton of red metal. We do this one part, and it ejects a 1 inch by 1 inch by 1/8 inch aluminum pad. And I've grabbed so many of those over just for like a clamp pad, trims.
Right. Well, that's the reject. That's the waste.
Yeah, that's the waste.
Great.
But it's like a perfect, little.
Sure. Oh my gosh, so much.
But yeah. So this, for example, the part.
I saw that on the machine with the Epson robot.
Yeah, and it's ejecting as a flat blank. It's ejecting these little ellipses, and then from the sides.
Yeah, look at that.
Oh, it welds it. Also.
It's cutting
A relatively thick
and
part.
then 45, I think 1 mil, and then it'll roll it and laser weld it along the seam.
Amazing.
And then after that, it actually swages it and then crushes it. And so
for final sizing?
It final sizing and circularity.
Really?
Yeah, we're holding the roundness and diameter across these points within a thousandths. So,
What sort of part is that?
it goes in a steering system on a lot of German vehicles for electric steering assist instead of a hydraulic power steering motor. It's electric, but you know how sometimes if you grab a servo motor, it kind of that does that on a steering wheel too. And so this, because of the thin nature of it and the cross section, kills the vibration from coming up into your steering wheel and you feeling it.
Really?
And we make two versions. This is the standard version, and then there's a high performance version, which is a little different shape, and that kills the vibrations even more.
Interesting.
So, these are what we looked at just a minute ago was a Bihler.
Yeah.
And these are like the next generation of Bihlers. And project for these just currently got canceled, so we're in the process of tearing them down.
Oh, geez.
This was a lot of work, and we're just all ripping it off. But it's basically a 500 millimeter square grid plate, and you can drop modular components anywhere on that grid system. Like the press head, for example. This is another one of those.
That's the press. The only section of the press head's right there.
Yeah. And so you could put one of these on, you can put 5 of them on.
Oh, the press heads themselves are modular.
Yeah, the whole thing.
Wow.
And so that's the feeding system. It feeds into the press.
Yep.
We'd have a die in there and stamp something. And then maybe the next station we have a servo tapper or a pick and place robot dropping a rivet.
Wow.
So the idea is you can get set up on a job a lot quicker using off-the-shelf components, dropping them onto a keyed grid.
Yep. Interesting. Totally different design as well versus these giant 20-ton casting systems.
And this is what this was making. This is a stainless steel battery housing, and it was stamping it up, folding it, squeezing it, laser welding that, then flipping it onto the side, and drop a lid in it, and then laser weld the perimeter. And we were doing 20 a minute.
20
which
a
is
minute?
really slow for us. That is glacial pace.
Wow.
And then this machine was set up to do the lid to that. That's a BM3000, which means it has 3,000 millimeters of bed length. This is a 1500, so that's referring to the box casting. So we have 1500 millimeters, which wasn't quite enough. So we put 300 millimeter extensions on.
Okay.
And that is a good example of something we did on the decker. So I bolted that all up,
and then I was able to cross drill and dowel those plates as a box.
Very accurately.
And cheap way to make an accurate big box. But,
Interesting.
so for this one, we actually were stamping the lid.
Whoa. A big
So this
feed
is
bowl.
a bull feed.
Yeah, right.
And we stamped the lid offline, and it feed bowled in.
Yep.
There's one hiding right there if you want to try to grab it.
Okay, that was already made though. That's,
Yeah.
Okay.
So this got stamped on one of our larger presses, and then they would come off that feed bowl into this conveying track. That introduces it.
Oh,
to
sure.
This,
There's one right there.
yeah. This point.
And the robot would turn it.
Drop it.
Yes.
Into just. This is just a stamping strip. We made this on a progressive die. We had one shaped like this.
Oh.
And so when this is
It's just a
fired up,
conveyor belt.
when this is fired up, an air cylinder will accumulate the slack out of it.
No
and,
kidding.
That's how we convey the part from
Sure.
station to station.
Huh.
If you guys want to see an engineer practical joke, this is a 5-spoke. On the other end, we made it a 6-spoke.
Just to be funny.
The guy who did it thought it was the funniest thing ever, but it really torqued somebody off. So.
It's amazing.
But yeah, so again, a laser welder, it would drop inserts into each one of these holes. And then this is a gimbal head, so it has a rotating and tilting mirror. And it would weld patterns, and you can see a welded one here.
That's the laser welder there. So it's like a galvo laser where it can angle or point. Okay, there's the...
Yeah, and that's called a glass to metal seal. So it's 2 stainless steel tubes, but there's a glass layer in the middle, so there's no...
2 stainless steel tubes.
So there's no electrical conductivity. And then that little kind of checkpoint looking thing is called a burst disc.
Oh.
And so if the pressure of the battery gets too hot, it'll pop.
Right there, though.
Hey John, do you have any like statistics like pounds of metal a week and parts shipped a week and shipments? And
We do.
I've heard them, but I mean they're so hard to retain.
So high-level statistics for 2018 were 1.2 billion. That's billion was a B. Shipped. Just over 6,000 shipments. 98.4% were on time, and we had 15 customer complaints.
1.5.
1.5.
Wow. And is that progress? That's better than 17, better than 16?
That's correct. We were awarded a new project that we launched in 2018 that took us from 130 million a year to 1.2 billion. And that's primarily that electrical contact that we mentioned. That number, 2019, we should top out around 2 billion parts.
Oh my God.
So people ask me, how do you do that? It's a really simple answer, one at a time.
Yeah. One at a time. But I could sit there and watch that press for hours.
Yeah.
Amazing. The way that servo taps in 300 milliseconds, bends that part up, welds it in. It's amazing. It's like why I always love machine guns. I don't care about the nature of a machine gun. The mechanism that's functioning so intricately at that speed is amazing.
The mechanism at that speed is amazing.
Yes.
I mean, basically, when it comes down to what to do things fast and to do things precisely, you just have to factor everything down. So, for example, when we stamp at these speeds and hold tolerances of thousands to statistical capability, that just means that your tooling has to be 10 times better.
Yeah.
So whatever tolerance you want to hold, the machine or the mechanism that you're doing it with has to be 10 times better.
Yeah.
As long as you can achieve that, you can hold the tolerance.
Got it. Hence the decals and jig bores and so EDMs.
So I mean, we have, from a production standpoint, we have 2 basic platforms. One is the Bihler, and then the other one is the high-speed Bruderer presses, which, again, speed and precision are their primary components. The differentiation is this. A Bruderer is very high speed, has one motion, up and down. The Bihler is not as high speed, but combines operations, welding, stamping, forming, all into one. So in an application where we've got high volume, typically it has to be more than 1 million parts a year. You combine operations, go from raw material to finished product in one process.
One strip, yeah, in and out. It's amazing. Seeing it feed in that silver in the Bihler, weld it, yeah, that's amazing.
It looks easy.
Yeah, oh yeah.
But Adam can attest to the fact that, it's not.
Right.
I mean, it takes just a lot of conscientious people to sort through the problems and get it to be right.
Yeah. Thanks again for letting us come see the facility and tour. This is really impressive.
It's taken a lot of time and effort, but I mean, you have a machine shop too, right?
Yes, but
so
much more modest than this.
This started in a 2-car garage.
Is that right?
Yeah,
2-car garage.
2-car
what
garage.
Year?
1987.
1987.
We started with a milling machine and a decrepit grinder. I mean, a really decrepit grinder, and more ambition than sense.
Yeah, I think that's what's so interesting is that it's hard to relate to this when you come in and you see this facility producing thousands of parts per minute, accurately, reliably. There's key metrology systems in place. There's employees, but you built this. You built this from nothing.
I always say I'm like a turtle on a fence post. I didn't get there by myself, right? I mean, turtle could never climb up there.
Sure.
Yeah. No, I've been fortunate over the years to have had the right people come along.
Yeah. It's also cool to see multi-generational businesses, but boy, to think that this didn't exist in 1986.
So my dad, I grew up in a family business.
Uh-huh.
So I grew up Amish. Started working for him full time. He believed in child labor.
Mm-hmm.
So I was sorting parts that came back from platers when I was 6, 7 years old, not because I wanted to, but because I had to.
Yeah.
And then I started working full time when I was 13.
Wow.
I built my first progressive die at 15. And then decided at age 24 to leave the Amish, and that cost me my job and everything. So
Wow.
I had a garage, so that's how we restarted. And
wow. Cool. Hey.
I'll get some printed material for
Okay,
us.
thank you.
Expand on John. We actually have our apprenticeship in house.
Okay.
We're certified with the state, and what we're doing is we're riding on a local technical school's charter.
Okay. Yeah.
But yeah, all of our teachers are superb employees who have journeymanships, and so we're creating our own tool and die makers in-house to our curriculum.
Yep.
And it's a 4-year process for tool and die maker. We have stamping technician, which is a 2-year process, and we even have state journeyman positions for office workers.
Really?
Yeah, that's a very common thing in Germany, which is where we modeled this program off of. So that helps to be able to put somebody through a formal system of handling documents and
familiarity with the language and the terms and the processes.
Yeah.
Sure. Interesting.
So
It feels more like a German apprenticeship.
well, John actually lived in Germany for a while.
Okay.
And he worked for Bihler, and so that's a lot of this comes from that.
Yeah.
And we're always kind of comparing ourselves to German companies we work with and trying to push to that level. Let's go check out some more Bihlers.
There's a storage barn full of more. These things are very rare, so when one comes up used, you buy it.
You snap it. Got it. They're still making them though.
Yeah, they're still making them in all different formats like that, the cam-driven style. Those it made sense to buy new, but the cam-driven ones are so basic mechanically, you can rebuild them very effectively. Same setup, derailleur, off pancake reels, material straightener, and then we have our ytterbium lasers. kilowatt. And then that strip goes into the press.
What does the laser do?
What?
What does the laser do?
It's up in the by the Epson, but the system is there. Yeah. The diode is there. Fiber optic. Air cylinder disengages a set of punches every 3 hits.
Every 3 hits, this air gauge disengages a set of punches. Okay?
Yeah, and you'll see why later.
Yeah.
So, the blanked out strip, actually, let me just grab that. The strip that looks like this comes into the center ring, and we're going to grab it and roll it around. And then we'll have the 2 seams and then we'll face it. Now when that yoke plate rotates, it's driving cams that wedge it out.
Opening up.
At the top you see the IPG laser. When it cycles, it's running that seam well.
Right there's the laser.
Yeah.
What's this? A annealing furnace?
Parts washer. These have to have a really tight cleanliness spec. So, out of the parts washer, they have to get stacked. Now eventually that'll go robotic, but they have to be oriented in the tray so their automation system can grab them correctly. And then from there it goes into a VCI bag and it gets boxed. Surface plate guy. Yeah, the guy lap your plates. Yeah, the guy lap your plates. About these. Let me go grab the part this gets attached to. This is another electrical contact for water tanks, I believe.
Okay.
And so it's coming off a de-reeler. And this is thinning up material we don't need a straightener. Just that curve there will straighten it. Goes into an air-fed die, and then on the other side, it's
I didn't notice it comes into the
putting the ribbon. And then this is a contact welder. And it's putting in contact and resistance welding it.
resistance welding it there. Wow. So these are connected together.
Yeah. So that's the same strip coming out the other end. Bye. Alright, so from this reel, we're going to go to the back side of the neck press.
So that reel, that goes.
put them into the backside of this press, which is going to cut each part off and then assemble this one. It'll put the stainless steel part that's yet to be made onto this one and resist them so well they'll freeze together.
It's beautiful.
And what's eventually going to happen is we'll have one machine built onto the back of this that eliminates that. With it turned off, you can get some close-ups of the action on the front. So this is actually a low-profile press head where the cam pulls and the whole thing cams down.
Okay.
So this part starts life on this strip oriented like this.
Wow, so it's 3 strips coming in together.
Yeah.
Wow.
And you know, just kind of you can see the cut.
Oh, that's the drop. Yeah.
And we start roughing material off of it and to get to this final shape. And we do that. First stop is the press head again. It's just another cam-driven press.
Yep.
And you can see on the other side what the end result is.
Okay, yeah. Yeah. Hold that up there?
Yeah, and then we have 2 more servo feeders.
So that is... that right there, got it. Okay, coming across.
And so these servos will tap that thread in there.
That's easy. That's the servo tap right there.
And the way these work's really neat. All the servo is doing is rotating. There's air pressure that pushes the tap down, and so the tap sets its own lead.
Okay.
And then when it's done, there's a vacuum that pulls the quill up.
It just follows the lead.
Yeah.
So it's
And
actually not precise.
You get a real nice, gentle tap light.
Is it a form tap?
Yeah.
Or cut tap?
Form. And then down here, it just comes through and then it gets piloted. All these do is locate the strip, and then this is when we start feeding in.
So, okay.
Oh, here's Brittany. What? What? Oh, run? Okay. She's having problems. It may not fire up. She's jogging it through right now, kind of proving it out. Advantage you didn't see previously through there. So you can see the automation of what's driving the sway